Today we're going to be learning Kruskal's algorithm. Kruskal's algorithm. And in Kruskal's algorithm, it is finding the minimum spanning tree, the MST. Recall that the MST, if given these edge weights, that the minimum spanning tree of this graph would be this, as it is the most cost-effective way to connect all these nodes. Now, Kruskal's algorithm uses a forest, so it uses a forest type data structure. And what that means, sort of imagine a game of tic-tac-toe with n people. So these are n disjoint people, and each person is going to play tic-tac-toe with somebody else. If this person wins the tic-tac-toe sort of matchup, this person over here must follow them. This person becomes the new leader. And everybody is going to go around playing this tic-tac-toe game, and everyone's going to keep following the leader that beats them. So this is going to create sort of, from disjoint nodes, we're going to get these sort of leaders. So if I ask this node, who is your leader? It's going to say, my leader is this. This leader is going to return, this is my leader, which is going to return that this is my leader. This is sort of the backdrop of how Kruskal's algorithm works. It's going to start out as n disjoint nodes, so all the nodes are going to be disjoint, and we're going to sort the edge weights. So if these were all the edge weights, we're going to sort them from least to largest sort of edge weights, so the smallest to the largest edge weights. And then we're going to go one by one and add them such that no new connection is already a part of the component. So if I were going to add these connections, I cannot add this third connection at the bottom. I cannot add this third connection. If those two edges were added first, I cannot add that third connection. So let's go through and trace Kruskal's algorithm. So it turns out that working through Kruskal's is actually pretty fun or pretty lightweight. So we're going to look at these smallest edge weights and work our way up, making sure that we don't create any unnecessary connections. So let's just choose this one here. Let's start with 1. So we're going to have these nodes now. Now let's look for the next one. We have a 1 here, we have a 1 here. We're just going to work our way all the way up to the largest. So we can choose this connection. So we're building our way up. So there's number 1s. We can get this 2 here, this 2. We can also choose this 2 over here, this 2 over here. Now we're out of 2s. Let's look for 3s. There's a 3. Well, we cannot add this 3 because it would be connecting sort of part of this. We already have this component being built here. There's no reason to add this connection. It's not adding any new connection to any disconnected sort of tree or forest happening here. So we're going to look to the next 3. You see that this next 3 is going to connect these new components here. This sort of tree with this tree. This is the end of Kruskal's algorithm, and we see that we have this MST. We can't go any further without incurring anything unnecessary. Here is an implementation of Kruskal's algorithm. So let's walk through this. We create the min heap to allow us to sort the edges for us. So we create the forest data structure here. And so really all this section is right here, is sort of inserting the weights into the min heap to organize those for us in ascending order. So now that we have that, the main thing that we're really going to be looking at is this line here, this line. So we extract from the min heap, so we take out an entry, and the entry goes as follows. We're looking at V, and between V is our weight, and we have U. So if we're evaluating sort of this forest, if we have this sort of forest going on, and we're looking at this component, the main thing we want to look for is, when evaluating this new connection, once we're looking at this, you want to do a forest find, sort of a find on this node, so this node V, and a find on this node U to make sure that they actually aren't a part of the same component, that they aren't a part of, if there's this connection down here that they don't actually share the same leader. You want to make sure that they don't share the same leader. And if they don't share the same leader, say if U's leader was this guy over here, or U was the leader, that then this new connection that we're examining is okay to add. So we can then go ahead and add this if we can't find that they have the same leader. And by the end of this, we're going to be finding the MST. So that's the basic rundown of Kruskal's algorithm. Now, the big O of Kruskal's algorithm, so the big O of Kruskal's algorithm are the edges. So we can say the edges log E, the edges again. As that bottleneck comes from the sorting that we're doing here, the sorting with the min heap that we're using, we get this E log E. And that is the end of this video. I hope you enjoyed, and if you did, don't forget to like and subscribe. If you are looking for this code implementation, you can go to the description and open the implementations folder, and you can find an implementation of this exact algorithm. It is accompanied by an open source textbook, so feel free to open a pull request or issue a Git issue if you find some grammar issue anywhere. And with that, thank you.